Hi everyone, this video is on exercise 13C, the challenge question. So in this video, I'm going to do question 1, which is an interesting question. So the question might seem confusing, but if you understand this recursive relationship, then you can easily answer the question. So essentially, it's just saying that we have some equations. So y is equal to f of f1x, y is equal, and then y is f2x, and so on, where the derivative of the next term is equal to the function of the previous term. So this simply means that let's rewrite this as, so the derivative of the second function is equal to the first function, or the derivative of the third function is equal to the second function, and so on. So that's basically the relationship here. And now we are given that the first function, f1x, is equal to x squared. So in part A, we want to find f2x. So if we want to find f2x, remember that we have f1x, which is x squared. So let's substitute that here into f1x. If we substitute into f1x, we basically have this equation which says f2 dash x is equal to x squared. It's basically saying that the derivative of the second function is equal to x squared. So if we want to find the second function, we just need to integrate x squared. So we can then write f2 of x is equal to the integral of x squared with respect to x, which is equal to 1 over 3 x cubed plus c. But to find this constant term, we just need to use the fact that each curve passes through the origin. So when a curve passes the origin, it just means that if you have your x as 0, then your output is also going to be 0. So substituting basically 0 is equal to 13 times 0, that gives the value of c as 0, right? So because when a curve passes through the origin, that means the y-intercept is 0. So for all of these functions, the c or the constant of integration is going to be 0. So yeah, so we found that f2x is a third x cubed plus 0, in fact. So let's write that here. So f2x is equal to third x cubed. All right. We are not done yet because we want to find f3x. But as I wrote here, so f-3x is equal to f2x. So again, it's just the same thing. So the derivative of the third function is equal to the second function, which is a third x cubed. So we just integrate the second function. So we have for f3x is equal to the integral of a third x cubed dx, and that gives us 1 over 12 x to the power of 4 plus c. But again, we know that c is equal to 0, so f3x is just equal to 1 over 12x squared. All right, so this is the third function. Now for part B, we want to suggest an expression for f of f and x. So that's just the general term of this sort of maybe sequence. So if we want to find the nth term, we just need to notice the pattern, which is not very obvious. So if you start with, for example, f2x, which is here, you can see that you have the fraction with denominator 3 and then also power of 3. And then when you look at f3x, you see the power of 4, and then the denominator is 12. But 12 is essentially 3 times 4, right? So let's rewrite this as 3 times 4. Now let's find f4x, just, we can find the pattern. So if we want to find f4x, we just need to integrate f3x. So it is 1 over 12 x to the power of 4 dx, and that is equal to 1 over 60 x to the power of 5. And plus c, but again c is just 0. So yeah, f4x is equal to 1 over 60 x to the power of 5. Now, getting back to finding the pattern. So once again, f2x has the x has power 3, the denominator has number 3. Then f3x has power 4, the denominator is 3 times 4. And f4x has power 5, and then the denominator is actually 3 times 4 times 5. So the point here is that for whichever term you have, the power is 1 plus that. So if this is the fourth function, the power is 1 plus that. So as you can see, this is the pattern in f2x and f3x and f4x. So we can write f and x as x to the power of n plus 1. So that's the first thing. And the second thing is about the denominator, because the numerator is just 1. So in terms of the denominator, as you can see, for each term, the denominator is essentially the previous numbers times up to the new power. So for example, here the power is 3, so you already have 3 and the power is 3, so you don't do any multiplications. But here the power is 4, so you do 3 times 4. Here the power is 5, so you do 3 times 4 times 5. So that means you just keep doing this multiplication for the denominator, like 3 times 4 times 5 times let's change this slightly, so times 5 times 6 until you have n plus 1. So, and also for your x, we said that it's just this nth term plus 1. And yeah, so this is the nth function. Yeah, so it's not a standard exam question really. It's just more about applying what you have learned and just have a bit of challenge.